Hello, everyone. My name is Andrew Grassoff. I will be your moderator today for this LoRa Alliance webinar on uh, use cases for LoRaWAN in upstream oil and gas applications. We have a few different presenters today that will be presenting on solutions for LoRaWAN in the industrial space. But before we get started, a few housekeeping notes. Number one, we will have a Q&A session at the end of this webinar. If you have any questions leading up to Q&A throughout the presentation, please feel free to send them in and they will all be addressed at the end of the webinar. And this session will be recorded and made available on demand with any supplemental information and contact information for all of the speakers. So a high-level overview of these buzzwords that are commonly thrown around in the industrial space: Industry 4.0, the digital transformation, IIoT, but they aren't commonly regularly defined. What it breaks down to is what's being referred to as the fourth industrial revolution. And how that breaks down is everyone's familiar with some of the previous ones, right? The first one being power using water and steam. The second one being the implementation of the assembly line in manufacturing processes. The third being the revolution of the computers and internet in manufacturing processes. And now our fourth, which it's utilizing these common buzzwords like AI, machine learning, edge computing, and essentially all we're doing is we're connecting things out in the field to the internet, right? Hence the Internet of Things, IoT. And where we're working is the Industrial Internet of Things, IIoT. And what IIoT is doing is it's not necessarily replacing existing infrastructures or people in the field, but it's making those infrastructures more efficient. It's making those workflows more efficient. And it's giving us the ability to collect data that was previously inaccessible and turn around and make more informed decisions using that data. Right. So how does this apply to upstream oil and gas? As our audience is well familiar, upstream oil and gas is very remote. It's harsh environments and it's very data starved, right? It can be very difficult to collect stranded data in upstream oil and gas environments for those applications like asset health monitoring, for safety, for predictive maintenance solutions, for just general operational visibility. With existing solutions, you may be looking at a very costly or logistically impossible solution for running wires to collect data, or you're sending personnel out on unneeded truck runs to take time-based measurements. And what we're moving towards with IIoT is the ability to monitor and maintain equipment on condition-based increments, right? Moving away from time-based monitoring and maintenance to condition-based monitoring and maintenance. So enter LoRaWAN, right? And we'll talk a lot about LoRaWAN on this webinar in a little bit more detail soon, but the LoRa Alliance is who's hosting this webinar. It's a global, open, nonprofit organization that develops and maintains the LoRaWAN standards. The group presenting to you is part of the Industrial Working Group of the LoRa Alliance, which focuses on how the technology applies to the industrial space and helps make recommendations for moving the technology forward as applicable to the industrial space as possible, right? So the presenters here today are all part of this alliance. We have Abiwe, Aloxi, and Waika presenting on field instrumentation solutions. We have Tektelic presenting on the LoRaWAN technology and gateway infrastructure. We have Actility presenting on the network server infrastructure. And then I'll be talking about the SiteSync solution as the sensor and data integration tool for bringing all of this together. But our objective here is to show you how all these organizations work together in a LoRaWAN architecture to provide you as the end user in the upstream oil and gas space with real high ROI use cases for collecting data and turning around and deploying it at scale. But we're looking at wireless from a very fundamental approach, right? When looking at wireless data collection, you have a number of different protocols available to you. We find these to be pretty complementary when looking at it from an application perspective. What's shown on this slide here is what's called the wireless triangle, and it shows the three main desirables that we want out of wireless communication. We want long distance, we want high data throughput, and we want low power consumption. And with existing wireless out there, you're forced to pick two of these three, right? Consider common examples. Wi-Fi, right? Wi-Fi does well with data throughput, it does well with power consumption, but it doesn't optimize long distance communication. Cellular is another one that's very common. Long distance communication, it does very well with. Data throughput, it does well. But cellular is very power hungry, right? You charge your phone every night when you go to bed. Where LoRaWAN enters as a complementary wireless communication is it's optimizing long distance communication and low power consumption. And I show this and I talk about this to emphasize that complementary nature of wireless. You may be using another wireless protocol for a certain use case, but LoRaWAN is being adopted as the industry standard for collecting data, small data packets, sending them over long distances with batteries that last upwards of 5 to 10 or more years. Now we'll talk more about LoRaWAN, but like I said, it's being used as the industry standard for collecting data at scale and feeding those digital transformation uses of AI models, machine learning algorithms, of predictive analytics. So with that, I'll hand it over to Jack Stewart with Tektelic, who will take it from here.
All right, thank you very much, Andrew. Hello, everybody. My name is Jack Stewart, and I'm a business development director with Tektelic, based in Calgary, in Canada. I appreciate the opportunity to speak with all of you today and to share how LoRaWAN is helping to modernize upstream oil and gas operations. First of all, thank you to the LoRa Alliance for organizing this great event, and of course, for including Tektelic today. At Tektelic, we design and manufacture carrier-grade LoRaWAN infrastructure and complete network solutions. We've been supporting oil and gas customers both directly and through partners such as SiteSync, who Andrew just introduced, all over the world for many years. And my focus today for this webinar is to give a clear overview of the LoRaWAN technology, why it is an ideal technology for upstream oil and gas operations, and how Tektelic specifically has been developing solutions for hazardous locations that are enabling the LoRaWAN technology to scale across the industry. So what is LoRaWAN? To begin, I'm just going to provide a brief introduction about the technology. LoRaWAN stands for a long-range wide area network. It's a wireless communication protocol designed for IoT applications that require long range, low power, and secure data transmission. These are typically involving battery-powered sensors that need to operate for many years without having to be maintained, or batteries replaced, recharged, anything like that. LoRaWAN is optimized for sending small amounts of data over very long distances, which is really ideal for industrial sites where assets are widely distributed. It operates in the unlicensed or ISM band, which allows operators to deploy private networks literally anywhere without having to rely on existing coverage, without having to rely on cellular coverage, and without having to pay recurring connectivity fees for a more, I'll call it subscriber-based communication network. LoRaWAN is also an interoperable standard, which is backed by a very large global ecosystem. There are thousands of device types and complete solutions available throughout the LoRaWAN ecosystem, which gives users the flexibility to select exactly what fits their specific needs. So in short, if LoRaWAN is a new concept for you, and there's one thing to remember from this introduction, it's that LoRaWAN provides long-range, low-power communication from simple to deploy wireless devices and is an open architecture that really forms the foundation of modern industrial IoT. So why LoRaWAN for upstream oil and gas? Let's look specifically at why this technology has kind of emerged as such a strong fit for upstream oil and gas applications. As all of you know who have joined this webinar today, This industry operates across very large and remote areas. Sites experience extreme environmental conditions. There's often limited wired power or cellular connectivity available. RF obstacles like steel vessels, pipelines, and other structures can make wireless communication very challenging. And many of these assets have never been connected simply because it was too costly or too expensive to do so. And LoRaWAN addresses these challenges directly. It provides long range coverage with very little infrastructure required. The low power advantage provided by LoRaWAN allows devices to operate for 5 years, 10 years, even longer without recharging batteries or having to, go to the field to replace a battery, which of course significantly reduces the maintenance burden when deploying the solution. And LoRaWAN provides excellent RF penetration. So signals can pass through those difficult materials that I had just mentioned, like steel and concrete, much more effectively than many other wireless technologies. It performs very well in harsh environments, is simple to deploy, and has very low operating costs. The ecosystem now includes many off-the-shelf sensors designed for oil and gas use cases specifically, such as tank monitoring, pressure and flow, valve position monitoring, vibration, predictive maintenance, many of which you'll see examples of later in this webinar. And there's a growing ecosystem solving the most common problems and challenges of upstream oil and gas operators today. So taken together, all of these attributes are really the reason why upstream oil and gas has become one of the fastest growing verticals for LoRaWAN adoption. So let's take a moment to walk through at a very high level how LoRaWAN works. The architecture is very simple and it's very well suited for industrial deployments. At the edge, you have sensors or devices that are collecting operational data and transmitting small packets of information over LoRaWAN. These messages are received by a LoRaWAN gateway, and that gateway acts as the bridge between those field devices and the central network. From there, the data is forwarded securely to a LoRaWAN network server, which Actility will talk more about in a minute here. And that network server manages things like device authentication, decryption, packet routing, and is really I'll call it the overall intelligence of the network. Once processed, the data flows into the application layer. This could be a cloud dashboard. It could be a very comprehensive platform like SiteSync. It could be an on-premise system. It could even be like a SCADA or a PLC environment. One of LoRaWAN's greatest strengths is how easily it integrates with existing industrial systems, such as SCADA or PLC-based architectures. LoRaWAN does not replace those systems. It simply extends them by providing new data points that can be delivered through common protocols like Modbus, MQTT, or other common APIs. And this allows operators to enhance their current infrastructure without having to redesign it. LoRaWAN therefore provides simple, open, and scalable architecture that blends seamlessly with traditional industrial systems. Now, when it comes to LoRaWAN deployments in upstream oil and gas, Tectelic provides complete network solutions to address the most common challenges. And one of the most important contributions that we've made is in the area of hazardous location LoRaWAN infrastructure. For almost a decade, the industry lacked hazardous rated intrinsically safe gateway options. And this prevented many LoRaWAN projects from expanding beyond small pilots as operators were forced to mount gateways far away from the equipment that they needed to monitor, which is possible with a long-range technology like LoRaWAN, but it's not always feasible. And so Tectelic made a significant investment to solve this problem, and we engineered a portfolio of hazardous location gateways designed specifically for oil and gas environments. Arcona Macro EX is a certified Class 1, Div 1, and ATEX Zone 1 compliant gateway, which allows it to be installed directly in the most hazardous locations. Arcona Mega EX is a certified Class 1 Div 2 ATEX Zone 2 gateway, which is ideal for sites that require intrinsically safe infrastructure near the production area. Both gateways use industrial grade components, support extended temperature ranges, include high RF sensitivity, and have integrated environmental protection such as lightning and surge suppression built right in. They support cellular, Ethernet, and satellite backhaul, which enable deployment anywhere, even in the most remote locations. And these gateways are not simply certified products. They eliminate a critical barrier that has held back large-scale LoRaWAN deployments in oil and gas for many years. With hazardous rated infrastructure now available, operators can confidently deploy LoRaWAN across their entire operation. And Tectelic is very proud to have brought this capability to the oil and gas sector through deep engineering focus and investment. So to close, I just want to highlight the real world impact that LoRaWAN is having in this industry. First, LoRaWAN reduces both capital and operating costs. The long-range capabilities reduce the need for dense infrastructure, and the low-power nature of LoRaWAN devices minimizes or eliminates the need for field visits for battery replacement. Second, deployment is very fast. Networks can be installed in days and expanded gradually as new use cases emerge. Third, LoRaWAN enables near real-time visibility into assets that were previously unmonitored or very costly to monitor. And then finally, LoRaWAN integrates directly with SCADA and PLC systems, which means operators can modernize their operations without replacing existing architectures. At Tectelic, we are committed to supporting the oil and gas industry with carrier-grade LoRaWAN infrastructure and solutions that are reliable, safe, and built to last. And if anybody would like to learn more, I'd be happy to connect with you after the session. So thank you very much for your time. I'm now going to hand it over to Adon Sequeira from Actility.
Thank you, LoRa Alliance, for this opportunity, and thanks, Jack Stewart. So I'll be explaining about industrial-grade network infrastructure from Actility and geolocation solutions from Abbey. So Actility has developed a network infrastructure solution for enterprises using LoRaWAN technology called as ThinkPark Enterprise. It comprises of a network server, joint server, and a nice user interface for device, gateway, and application management. This solution can be installed via SaaS, private cloud, or on-premise. When it comes to various factors in terms of value add in a network infrastructure, I will be highlighting more into security, reliability, and scalability. So security. Actility, LoRaWAN by default is a technology which is end-to-end secure from the devices to the application server. It comprises of two parts: LoRaWAN MAC layer security with multiple device keys and LoRaWAN app layer security for the device payload. Actility provides additional security to the backend itself via IPsec, TLS, and firewall protection against cyber attacks. It also supports authentication via SSO, single sign-in, to make sure that you don't have multiple people accessing the same credentials, for example. In terms of reliability, there are two facets, you can say. One is gateway reliability, and another is infrastructure reliability. In terms of gateway reliability, Actility has developed a small piece of software which is installed on the gateways called LRR gateway software. And this software makes sure that packet buffering is done when there is backhaul outage. For example, if there's no 4G on Ethernet, it does buffering. And it also supports network interface failover. For example, if the Ethernet is not working in a particular gateway, it can automatically switch to 4G and satellite, for example, as a backup technology. In addition, Actility also supports multi-gateway macro diversity to make sure that there is no packet loss. Infrastructure reliability. Now, this comes around disaster recovery, and this is very important. So, Actility is by default high available architecture in SaaS variant, whereas it is optional in on-premise variant. It consists of three components: active LNS, standby or backup LNS, and an arbitrary site to manage the role between the active and the standby and shuffle when needed. When it comes to infrastructure scalability, it is important to understand that a network infrastructure should scale from a small POC of 50 devices and one gateway to thousands of gateways and millions of devices. And to match with this, Actility has a carrier-grade architecture built for millions of devices and thousands of gateways. It also supports Kubernetes in on-premise deployments with adaptive load management. In this, we will be discussing about adaptive data rate mechanism, which was specifically developed with tier 1 operators and enterprises based on their battery consumption needs. So here, what advanced adaptive data rate mechanism does is it dynamically helps the devices to change its transmission parameters, for example, transmission power, number of transmission, spreading factor, etc., to make sure that the time on air is optimized. For example, here we can have 60% of optimization on time on air, which in turn reduces the battery consumption and also generates return on investment. So when it comes to network management and gateway management, Actility supports a zero-touch provisioning interface, and it is gateway vendor agnostic. For example, here you can see Tectelic, but we are open to other gateways as well. And it has same UI, same UX, and same API to give all the gateways a homogeneous behavior. Actility also supports advanced alarming, where all the critical alarms can be sent to the Network Operations Center via messaging and emails as well. Same like the device management aspect, same like the gateway management, in the device management as well, it supports monitoring and alarming. In addition to this, we can do QR code provisioning for the devices, which is standardized by the LoRa Alliance, and also bulk provisioning for hundreds or thousands of devices through CSV documents. This is my favorite part in terms of device management, which is about data interoperability and device interoperability. And to make sure that you don't waste weeks of time, Actility has developed a large library of 750 plus device models to make sure that you save time. And in addition, if it lacks a device driver, you can have your own new device added as well through just with this tutorial. Okay. So Abiway geolocation solution. So Abiway is a subsidiary of Actility working into LoRaWAN technology. Abiway develops cutting-edge trackers which are LoRa Alliance certified and EX certified as well for oil and gas projects. It supports indoor-outdoor seamless geolocalization, where it uses Bluetooth and Wi-Fi scanning for indoor positioning, and it uses GPS and low-power GPS for outdoor positioning. Along with the geolocation modes, it also has security features via SOS button, buzzer, and LED for user alerts. So now I'll be speaking about 2 use cases. So first is with Petrofac, which is an EPC contractor who wanted to help their customer in Oman with the challenges around workforce efficiency and also a solution to restrict people to go into unauthorized zones. So we recommended them MicroTracker Zone 2 devices or Division 2 devices for the US, where it was deployed among 1,100 workers dispersed among 3 work shifts. The benefit with this deployment was that they were able to achieve 28% of workforce optimization and 83% of better medical response over time. You can see more details in the LoRa Alliance white paper itself in page number 5. When it comes to the second use case, we did it with site-sync automation for Marathon Petroleum and ConocoPhillips, where we helped them into safety optimization and machine usage time optimization through Compact Tracker and Smart Badge. These 2 devices were Zone 2 compliant and was using GPS positioning and SOS alerting for Smart Badges. In terms of return on investment, we were able to have 80% reduction of time wastage, and $200,000 of annual savings per site. So this is a quick glimpse about the ABWay portfolio and which devices are available for oil and gas projects. So here, Smart Badge and Micro Tracker, both are Zone 2 and Zone 1 certified. They are battery rechargeable and both have buttons with it. The Compact Tracker, whereas it's used for asset tracking, is Zone 0 certified as well. And it also has two sub-variants, can say, which is Industrial Manageable Beacon, which is actually a LoRaWAN Manageable BAD beacon, and a Combo Compact Tracker, which is LoRaWAN certified as well, but also it works on cellular technology as a backup method. So when the asset is moving from one site and the second site is far away, it has seamless communication and you will get the data and the position as well of the asset. So next, I will be handing it over to Michael Mayer, Director of Aloxi. Thank you.
Thanks, Edon, and good morning, everyone. I hope you're enjoying the webinar thus far. My name is Michael Mayer. I'm the Managing Director at Aloxi. As some of the previous presenters partially covered, upstream oil and gas operations are high pressure, both literally and figuratively. Every operation in upstream oil and gas involves complex systems, tight schedules, and a necessity for safety, production uptime, and cost control. And in all this complexity, we're often one manual valve away from a major incident. The smallest misalignment in a high-pressure environment can escalate instantaneously. Over the next few minutes, I'll walk you through a real-life example of why manual valves continue to be one of the biggest blind spots in upstream operations and how misalignment drives non-productive time and even catastrophic risk. Let's talk about why this matters. Offshore operators pay between $300,000 and $900,000 per day for a deepwater rig. That's over $500 per minute of downtime. So a single mistake in a valve lineup during a managed pressure drilling MPD operation can easily burn tens or hundreds of thousands of dollars in non-productive time. So, and all during that downtime, the rig contractors keep billing while the operator keeps bleeding. This is exactly why drilling and completions engineers, company men, superintendents, production teams are laser focused on integration, safe operations, and protecting their P&L. When a valve is wrong, the knock-on effects can become quite expensive quite quickly. In MPD operations, pressure tests, kills, well control scenarios, day-to-day production handling, dozens of valves are operated every single shift. The industry standard today is visual checks, so sending operators into hazardous areas under high pressure, verbal communication over the radio, which can lead to human error, and then human memory during shift handovers, which can also lead to human error. And we all know this statistic. More than 75% of upstream incidents involve human error. It's not because people are careless, it's because these systems are very complex. There's a lot of things going on. The environments are very harsh, and humans have their own limitations as well. So operators are asked to validate thousands of manual valve operations with no reliable real-time feedback. And in a world of 10,000 PSI environments, that blind spot is unacceptable. So not only the statistics show this, but history makes this point painfully clear as well. So if we look at the Deepwater Horizon case, the investigation proved that the diverter system was misaligned, which sent gas to the mud separator instead of overboard. Well, this misaligned valve didn't cause the whole incident. It did dramatically escalate the event and increase the likelihood of ignition. What was the result? The cost was over $65 billion in cleanup, settlement, and penalties. And this isn't just an offshore drilling story. Valve misalignment caused tank overflows, flow diversion, pressure test failures, well control complications, and equipment damage across every upstream sector. One wrong valve can completely derail an entire operation. Now let's take a look at the solution. So here is why so many operators like Petrobras are mandating manual valves be monitored on offshore platforms. First off, it reduces risks of blowouts, kicks, and costly NPT events. As explained earlier, when a valve is misaligned, the consequences escalate quickly. Second, it provides real-time validation of valve position during MPD operations instead of relying on radio calls or memory during shift handovers. Operators can see the exact valve state in the doghouse or even in remote operation centers. Third, it gives automated assurance that the flow path is correct during these pressure tests. As pressure testing involves dozens of valve changes, our system prevents a small mistake from resulting in hours of delay or a failed test. And last but not least, it reduces human exposure to risk as well. No longer are operators needed to go walk into hazardous areas, into high pressure zones, just to visually confirm valve positions when our system is instantaneously reporting it safely. In short, it turns one of the historically largest blind spots in oil and gas operations into a real-time certainty. I'd like to close my section of the presentation with a quote from one of our valued customers, a senior upstream digitalization engineer, which I think illustrates and summarizes my slides quite perfectly. His quote was, "A single $500 valve position sensor can prevent up to $100,000 of NPT stop time or stop a blowout or hazardous event even before it starts." Our valve position sensor uses MEMS technology, an accelerometer, a gyroscope, a magnetometer, and it fits universally on nearly any valve used in oil and gas operations. They're also designed for the harshest of environments. Thanks to the hazardous area certification, IP69 ingress protection, shock-resistant housing, our sensor can operate in heat, cold, high vibration environments, corrosive atmospheres, and this is not just theoretical. We have tens of thousands of these devices deployed globally to date. So if you'd like to eliminate the human factor blind spots related to manual valves, reduce NPT, and de-risk pressure critical workflows, I'd be happy to take up your specific case and work with you to determine how LoRaWAN and our valve monitoring system can be deployed at your facility. And with that, Philip, I'll hand it over to you.
Well, thank you very much, Michael. So now, first, my name, Philipp Lausberger. I've been working for Vika since a few years now. And yeah, we as Vika has been in the oil and gas market since almost 80 years now. So we started as analog equipment manufacturer, having now a lot of also devices for pressure, temperature, level, and so on measurement. And today I've brought two use cases, two stories from our daily business, from the IoT business. And I want to show you, let's say, why LoRaWAN and those solutions are top notch for those industry and also to retrofit existing infrastructure and equipping new one. So the first use case we're going to focus is the oil and gas well monitoring, especially the monitoring for the casing and tubing pressures. So it looks like a little like this animation here. So today you find those analog gauges there, and also the well is placed in a cellar, which collects, let's say, leaking oil or oil spillage. And so you have today manual procedure behind to monitor the casing tubing pressure, because this indicates, let's say, in which condition your well is today. And because, let's say, monitoring of an oil well is not like a walk in the park. So Yeah, imagine, for example, or I've talked with a customer of us, with Ferdinando. He's in charge of 100 wells in a few hundred wells in Middle East. And so you can imagine what you need to do for just recording a single measurement. So you will have, no roads there. Those wells are wide distributed over a wide area. You don't, or even a small failure like a flat tire is really dangerous. So sandstorms, hot temperatures, and so on. And also, if you are at the well, you have always the risk that hydrogen sulfide releases. So that's a really high poisonous gas. And actually, if you are at the well, and you see you have some issues today, it will cause for sure environmental damage, pollution that causes cleaning costs. You need to stop the production. You need to pay fines for this. And last but not least, that will also cause PR damage. So everyone knows, let's say, the pictures in the newspapers or in the TV, and nobody wants to, be at the late night news. And so this is, let's say, really condensed how this monitoring procedure looks like today. So just to record one single pressure value of your well. So you need to plan which well do I need to monitor today. You need to prepare, then you need to drive through the well, and with those risks that you have, the driving costs, then you need to access walk to the well. And just if you are in front of the well, you see if the well is in a good condition, or if maybe a failure has occurred, and then you don't know when was the failure, or even if the well is okay, how will it be maybe 10 minutes after I left the well? And then you need to record the data and drive to the next well. And so this is really cumbersome and repeating procedure. So maybe one time per month for just a snapshot of your well. And how can you do that better? So you need to install a LoRaWAN device there at the well instead of the analog one. Then you have the infrastructure, which was perfectly explained during this webinar. And then you have at the end platform automized documentation. You will have anomaly detections, alarming, and for sure also the interfacing in existing SCADA systems, what you use today. So, and if you compare also, let's say, the time, what requires to be at your well. So just one recording will cost you maybe between 1 and 2 hours for just one snapshot. And if you would log in remotely, you had 1 to 2 seconds remotely at your well. So really simple. And so there's a bunch of opportunities what you can do. So if you require still an analog gauge there, you can use, for example, LoRaWAN certified radio units like the Netris 3 in combination with the pressure gauge. There are pressure sensors, temperature sensors, and also for the well level, or there's special ATEX sensors you can use, or if you have some specific requirements regarding the sensors, there's also some bridges available which translate, let's say, the standard 4 to 20 milliamp signal into LoRaWAN. So to summarize, today we have an analog system, or even, maybe you haven't for sure you have a PLC at your production well, but those systems are often decentralized, so there are local systems. And so now with low efforts, just screwing the old device out and putting a new in, and you can easily move to LoRaWAN and to a centralized data management system, and also to remote monitoring system. So And the last use case I brought, or the second one, is also really common use case because everywhere you find rotating equipment, so pumps, motors, in those motors, or even the damage of a small part like a bearing can also cause production loss. And so here, also the LoRaWAN or the general IoT approach shows really big the benefits. So in the past, you need to wire and so on and so forth, really high cost for those installation. This system will work battery powered, so you just need to glue at at a sensible point the multi-sensor on, and then you can record ultrasonic vibration temperature, and then you transmit it over LoRaWAN to the application server. And now you can use, let's say, the power of the Internet of Things of updates, and also to be always at the best transparency there. And so then you have, let's say, an anomaly detection, so a machine learning algorithm, which compares, let's say, how your asset moved over the time. So what if there is an issue, what is the physical phenomenon? And then also it predicts, let's say, what you will have for failure and what you need to do for a reaction. So that's really summarized. So you will have one ecosystem, LoRaWAN, and you have a bunch of applications you can easily equip then if you have the infrastructure, and you can also use machine learning. So that's all I want to present today, and then I'm gonna overhand to Andrew again, and thanks for joining.
All right, thank you. So like I mentioned before, we have a number of solutions that were presented on this webinar. Some of the industry leaders when it comes to deploying LoRaWAN in industrial environments, and it can be a very advantageous wireless protocol to use in industrial environments. It has many advantages, but like all communication protocols, like all technologies, there are some disadvantages with the technology. One of those being referencing that wireless triangle that I showed before, the inability to accomplish those high data throughput applications. Now, there are some use cases like vibration monitoring where you can push the limits and get a lot of data out of LoRaWAN collection, but for the most part, it's complementary to some other protocols in that it's targeting small data packets trended over time, implemented for watching data for predictive analytics to make more informed decisions moving forward. Another drawback with the technology, and it's kind of a double-edged sword where it is a pro that LoRaWAN is an open protocol and you have access to all these different sensor manufacturers with any sensor communicates back to any gateway, but that can be quite burdensome on the end user to implement at scale, right? Because each LoRaWAN sensor type from each sensor manufacturer requires a custom decoder to bring that data from the sensor and put it into a usable format and where I want to see that data. So that's where SiteSync comes in as sort of the easy button for implementing LoRaWAN at scale. Now, SiteSync is a platform built on the Ignition SCADA platform by Inductive Automation, and it is a sensor management and data integration platform that's used for implementing LoRaWAN at scale and making it easy to take the data from any LoRaWAN device and drop it off in a platform that I am used to seeing this data. Every LoRaWAN sensor has its own unique device keys, and each sensor type, as I mentioned, has its own unique LoRaWAN decoder. And all of that information is housed in SiteSync to where all our end users have to do is scan a QR code that comes with the device, and the data seamlessly flows through the architecture into a usable format. This can be deployed either as a cloud-based or on-prem solution, and it integrates into common SCADA platforms and data historians that end users in the upstream oil and gas space are already using. The idea with SiteSync is to make the deployment of industrial IoT as easy and simple as your residential IoT. As easy as it is for me to take a smart camera or a smart plug and deploy it in my house, I want it to be that easy for operators and technicians to deploy these devices at scale in industrial environments. Right? So we're bridging the gap between IT and OT and trying to make it as simple as possible to deploy sensors at scale. So, like I said, we have a number of different solutions that were presented to you today that are interoperable and work well together in what is the overall LoRaWAN architecture. And on this slide, you can see that data flow from sensor through gateway, through network server, into SiteSync, where the data is normalized, put into a usable format, and integrated into platforms that you're already familiar with, so that you can visualize that data alongside your traditional process instrumentation or in an easy to access cloud environment, so that you can turn around and make more informed decisions, either based on data trends with set thresholds or feeding predictive analytics models that can churn out operable solutions moving forward, right? So it kind of really drives home the use of this technology. You've heard a number of different use cases, and there are several more that are a part of the LoRa Alliance. Many different sensor manufacturers and solution providers that can be a useful tool in your LoRaWAN tool belt as a end user in the upstream oil and gas industry. So with that, we'll move into our question and answer session. If you'll just give us a few minutes to get this set up, we will be right back with you. All right. Thanks, everyone. We are moving into our Q&A, and we have a few good questions and comments that y'all have sent in. And if you have any other questions while answering these that come up, feel free to type them in the chat and we will address them. First one here, Tony had a comment. Tony Criggan, you had said that it's more than just long distance with LoRaWAN. A great application is radio frequency challenged paths over any distance. LoRaWAN excels in building or plant coverage, even over short distances. That's a good comment. You also shared that it has excellent performance in high attenuation and clutter environments, including penetration through metallic obstructions. Tony, it sounds like you are an RF person with a background, and you said that you value the emphasis that Tectelic has on the RF hardware design. Instead of focusing on the code and digital hardware design only, their use of cavity filters is groundbreaking on the LoRaWAN space. Thanks for that context, Tony. We appreciate your insight with your expertise on the technology.
Yeah, definitely, Tony. Appreciate your feedback, your comments. I'm glad to hear that you've been had success with Tectelic solutions. So appreciate that.
Okay. Our next question here from Joyanta. Question to Actility, Idan. Is it possible to install the LNS and location engine both entirely in a private network? And if yes, what are the drawbacks?
Yes, both the ThinkPark Enterprise can be installed on premise, which is private network in our case, and also the location engine for Abbey can be installed on premise. Yeah, in terms of drawbacks, is that the for the location engine, it needs to be a sizable quantity because there's a lot of operational effort needed. That's it.
Great. And then back to you, Idan. Ibanez, which is the precision of the GPS trackers of a B-Way?
You can have between 5 to 10 meters, depending on the satellite positions.
All right, and then here's a question for Michael, the Loxy. For the valve sensors, they are X or hazardous rated for which code zones?
So in the US, it's class 1 Div 2 rated, and then in Europe, it is zone 1. What we find is that 99% of all manual valves are in a class 1 Div 2 environment. Every once in a while, we'll get a customer who thinks they have a valve in a class 1 Div 1 or a zone 0 environment, and 99% of the time, they come to find out that it's actually class 1 Div 2.
Yeah, and I think an additional comment there. I think all of the sensor providers on this webinar do have hazardous area rated devices, either both for zone 1, zone 2, or US version, I guess zone class 1 div 2 and class 1 div 1. So very applicable for hazardous environments. Thanks, Michael. This is Lewis. Hi, could you please explain how the site sync works? Yeah, I would be happy to add more context there. Some more information can be found at our website, sitesync.cloud. It'll be provided in the references for this webinar. But SiteSync, again, is the sensor management and data integration platform for LoRaWAN. We've partnered with most of the LoRaWAN device manufacturers, network server providers, and gateway providers to have a clean integration into either a cloud visualization of all of this LoRaWAN data or into an existing platform where you may be already consuming process data. So a SCADA platform or a data historian or even a control system. We see it as sort of building that single pane of glass to bring any LoRaWAN sensor into a normalized format. And happy to talk more, Lewis, if you want to reach out directly. The next one, do you know examples of LoRaWAN deployments for fire prevention in oil and gas? The question relates to the need to secure alarm transmission and reception in a minimum time. Personally, I have not had experience directly with fire prevention in oil and gas. There has been some interest that I've seen with some end users with smoke detection and alarming off of smoke detection. Oftentimes, a critical measurement like a fire alarm is done with a wired instrumentation. Oftentimes, though, you may not have the ability to run wiring. So what's better than a visual check is a wireless check, and there are plenty of sensors available that can meet that need. It just depends on the specifics of the application. I'd be happy to discuss more with you on that. Remy, you submitted that question, and I'll leave a second open for any of our other webinar presenters to comment on the application.
I could just jump in quickly, Andrew. I'll just mention, I think there's a key kind of differentiator there between fire detection and fire prevention. And we do see a lot of examples of companies in the ecosystem deploying LoRaWAN solutions for fire prevention. So things like, methane monitoring, VOC monitoring, strategic monitoring of temperature of equipment that you want to ensure isn't, overheating. We see a lot of that certainly in the ecosystem, so more on the prevention side. There are certainly LoRaWAN fire detectors available in the market as well, as Andrew had sort of mentioned. Many of them operate in Class A because, which means oftentimes they're wired powered as well. Obviously, once you're doing like smoke detection and fire detection, you want to be able to transmit and uplink into the network like instantly. But on the prevention side, there are many applications for fire prevention for sure.
Thanks, Jack. Okay, our next question from Mustafa to Edon. Is there similarities between your solution for RTLS and UWB?
So yeah, Mustafa. So about RTLS, technologies, there are several technologies like ultra wideband, Bluetooth, Wi-Fi, and for outdoor positioning, there are technologies like GPS, GNSS, etc. Here, there is a combination because ultra wideband is a mesh technology. Okay, with geolocation for included. Whereas what we do is we don't use a mesh technology. We are using a star-based technology for LoRaWAN. And for the positioning aspect, we use Bluetooth and Wi-Fi for indoor positioning. And the added advantage is that you also have outdoor positioning. So you have an indoor-outdoor seamless approach, which is the major reason for us in terms of success in oil and gas compared to, ultra wideband technology. That's it.
Thanks, Idon. Yes, I would like to echo that. I found that the Abiway tracker is very advantageous having that multi-communication protocol available. Okay, next question is for Philip with WICA. Taking a quick glimpse at your products, they seem to be rated for Europe. Are there any plans to have these certified to other standards, North America and Canada? And it looks like Philip may be having some technical issues. I do know that the WICA platform does plan to come out with US certification. So that's the quick answer to that question. They will have the US 915 certification. If Philip jumps back on, we can revisit that and have him provide maybe more of a timeline. And then Kamal, are there any LoRaWAN vibration sensors for predictive maintenance? And although that was not a topic that was presented on this call, the answer is yes. There are several available. The WICA platform, I think, can touch on that. And it looks like Philip jumped back on.
Yes. So sorry.
No, you're all good, Philip. These two questions maybe you can address well from Hung and Kamal, one on the North American rating
Yeah.
and the vibration sensors.
Yeah, thank you very much. So sorry, I had some troubles with Zoom. So actually, yes, it's a really good question. So all devices, especially for ATICs, will be available in solutions for US as well. So we are worldwide. We have all worldwide our subsidiaries, and for sure the US and North America is also a focus market for us. And regarding the predictive maintenance, so this is where we see that Vika is also a holistic solution provider. So we have for sure the common where Vika is known for the good sensors, and here we have a special sensor for vibration, temperature, and ultrasonic monitoring to detect at really early stage the phenomenons, and then we can transmit, let's say, over a LoRaWAN network, for example, from activity from LoRa, doesn't matter, to the end platform where we have then the predictive maintenance. And this solution is also available in North America, Middle East, and also in much more countries. So this is a quite common application for us.
Great. It looks like there are no open questions now. So with that, we will wrap up the webinar right at the top of the hour. So good timing. I would like to remind everyone that this webinar, as well as the live Q&A, has been recorded and will be made available on the LoRa Alliance website. And one extra note that a survey will be sent out to all of the attendees. We do ask that you fill out that survey so we can get some quality feedback on how future webinars will be presented. We'd like to thank everyone for joining. Please don't hesitate to reach out to any of the webinar presenters. All of our contact information will be made available in the webinar references.
Thank you.